Okay, everyone. Hi. I think we can start the lecture. My name is Ainkaran Krishnarajah. I'm going to be a lecturer from time to time, giving this course over the next 12 to 13 weeks. Just a bit of background on the course. I don't know, Kumbesh, if you covered it already, but this course started 2 years ago. So Kumbesh and I put together the material that you're going to see over the course of the semester, covering mobile wireless, mostly around the 3G technologies that we have. So this is the third year running for this subject. And each year we try to update the slides so that you get the latest and current information as well. So just a bit of background of myself. I've worked in telecoms for about 10 or 11 years. I started working for Ericsson in Australia in Melbourne, and did engineering and computer science as my undergraduate degree here in University of Western Australia. So I'm from Perth originally. So I worked with Ericsson for about a year in Melbourne, and then worked in Sweden for 4 years, standardizing 3G technology with Ericsson. And that was quite an interesting experience between 98, 99 and 2002. So the first release of 3G was standardized in 1999. So what you see in your mobile phones is based on those standards, actually. And then, of course, like with any standard, it evolved and it was updated over the coming years, and technologies like HSDPA were added and things like that, and which we'll talk about over the next couple of weeks. And then I returned back home to Australia and moved to Sydney and started working with Ericsson as well, but in a more sales capacity. Technical sales, if you like. So my clients were Hutchison Telecom, and we launched the 3G network with Hutchison in April 2003, and that was the third launched 3G network in the world, so it was quite a new event for everyone. And then also with Vodafone Australia, New Zealand and Fiji were my clients for a couple of years as well. I left Ericsson earlier this year to join a management consulting firm, which is a European-based telco and media strategy firm. And so I've been working with them for about 4 years, and we specialize in a number of different things, from private equity clients to media, broadcast, telecom operators, government regulatory, all those sorts of things. So we provide advice and strategy consulting to them. The firm's name is Spectrum Value Partners. So if you're interested, you're more than welcome to have a look on the website. So what I'll do today is to take you through the first lecture. I do like it to be interactive, so if you feel like you have a burning question, please feel free to ask. I'm not going to shout at you or anything like that. I'm more than interested to hear your opinions and questions. And if you've ever had something that you're confused about and you want to discuss it, if it's relevant to the lecture, then please bring it up. Sometimes I might use acronyms, crazy telecom words that you may or may not have heard of. So please also ask, what do they mean? What's the relevance and so on as well. So that's perfectly fine. This lecture will run for about an hour and a half, maybe 2 hours, depending on how we go. So I'll try and finish by 9 o'clock at the very latest, if not 10 to 9, something like that. And also I'd like to take a break halfway through as well, so for about 5 minutes. Any questions to start with? No? All right, so if we take a look at the slides, you can see that we've got the schedule laid out as above. So today is going to be about the introduction of 3G mobile communications. Now, you might want to know why 3G and why not 2G and 1G. Well, we'll cover all of the different technologies as well throughout the course of throughout the semester, but the focus is on the most dominant wireless technology, which right now is 3G in terms of growth. Of course, most of the world is using 2G technology at the moment, but what we're seeing is rapid growth in 3G. So when you come out of university and looking around for a job, then 3G is going to be more relevant than 2G for you, I'd imagine. So that's where we'll focus. So this lecture today will be covering 3 broad areas. I'll give you some market information, some industry knowledge. Although this is obviously an engineering degree, it's always worth understanding some of the financials and some of the marketplace aspects as well. So I'll give you more of an insider industry view on things. And of course, we will go into deep technical aspects as well as the weeks go on, but I think you'll find also your labs and tutorials will be far more technical as well. So I'll give you more of an industry-wide perspective of things. So we'll cover the mobile marketplace, the history of mobile comms, the evolution from first generation to third generation, and now fourth generation is actually becoming quite interesting as well, if any of you have heard of what's happening there. And also, who are the industry players? Who are the ones that are making all the big moves, and where do they see things going as well? So I'll talk about that. And then I'll give you an introduction into UMTS, which is 3G in effect, if you like, a la wideband CDMA, and standardization, what is it, and why is spectrum important as well. And then we'll go into some detail around the UMTS architecture, which I think you'll find quite interesting. So moving on to slide number 5, if we look at the global subscriber penetration, so when we talk about a mobile subscriber, it's someone with essentially, if you like, a SIM card in the case of GSM and wideband CDMA technologies. Or in CDMA, you don't have a SIM card, so it's a phone. So in some markets, it'd be interesting to note that we have a penetration of the population of more than 100%. So that implies that there's more than one person with one phone. There's people with more than one phone in the country. That's what it basically implies. So if you look at Australia, we have roughly a penetration as of this month, June, July, of around 105% penetration, which is very high. And in some markets, like Africa, we have around 34%, but that's actually very high as well, given the type of economic environment of that continent. If you look at Western Europe, where mobile technology is quite mature, which is essentially where the biggest growth happened in the 80s and 90s, we're seeing penetration around 109%. So Europe is around 550 million people, so it's a significant number of phones there. North America, 85%, so Canada and the US, still very high. Interestingly, if you look at the numbers from 2002, 2003 for North America, it was only around 35%, which is quite low. So the US and North America were very slow at the take-up of mobile phones. It was mostly Western Europe. Then it moved to the Americas, and now we're seeing, if you like, explosive growth in Asia. So if you look at the 3 regions I have on the chart now, you look at Asia Pacific, it's about 41% of the countries there have a mobile phone, or the people have a mobile phone. But more interesting is actually India and China. China is around 44, as you can see, and India 24%. Each country is roughly over 1 billion in people, so 2 billion in total, so you can imagine the number of people with phones. But what's more interesting in India and China is that the number of subscribers that are added, or new subscribers that are added each month. Would anyone like to take a guess? It's roughly the same in India and China, so one number. Anyone like to take a stab? I'll give you a clue. It's in millions. 1 million, all right. Any other takers? 5 million? I'll give you a clue. It's higher than that. It's close to between 8 and 10. 9 works, yeah. So we're looking at, that's each country, mind you, not in total. So India puts on about 9 million per month, and China roughly the same, a little bit more, which is a massive number. So in 1 month, both countries have added the size of Australia, effectively, a 21 million population. So the growth there, you can see, is phenomenal. So what's happening in the world now is we're seeing a global penetration of around 55%, which is quite huge. And again, about 4 or 5 years ago, that was half that number. So the numbers doubled. So if you look at the chart on the right, it shows you the penetrations of subscribers by technology. So you have CDMA, wideband CDMA, and there's a typo there. It should be GSM. So GSM is the dominant technology here in dark blue. The light blue here is CDMA, and the red is WCDMA. Okay, so there's a bit of an error on that chart. Apologies. So what you can see here is that the GSM growth, which is the dark blue color, is still growing, but it's starting to slow a little. If you look at wideband CDMA between 2007 and 2008, it's effectively doubled. 138 million to 236, thereabouts. So what we're seeing is a massive growth in 3G globally. 2G is still growing, but not as fast as it used to. and CDMA technologies are starting to slow down. So CDMA, wideband CDMA and GSM, what are they? We'll talk about that in a couple more slides to come. So if we look at the technology market shares for 2008, as in the beginning of this year, GSM makes up about 82% of the global population, so that's the dominant technology. The GSM was essentially invented in Western Europe, if you like, and parts of, and in the US as well. So the main players were Motorola and Lucent in America, and in Europe it was largely driven by Nokia and Ericsson. So Ericsson was actually one of the key leaders in GSM technology at the time, along with Motorola, which somehow didn't manage to capture the lead. It sort of waned away, and the Scandinavian markets started to drive mobile technology at that time. Wideband CDMA makes up about 6%, but it's growing rapidly, as we've seen. And then there's a few other smaller level of technologies that are being used. In Japan, PDC, NMT is another one, which is actually a first generation technology from the 80s. So there's still a few examples around the place. So all in all, we have about 3.4, 3.5 billion subscribers on mobile phones at the moment, which is a huge number. So the mobile phone, the networks that we were talking about were interesting, but the networks would be useless without the mobile phone. So the two obviously need to work and interoperate together across all markets around the world. And it's not a big surprise that Nokia is the #1 market share in terms of mobile phone use. So it's 39% roughly. And Samsung has recently taken the #2 spot from Motorola, which has been #2 for almost 10 to 15 years, so quite some time. LG and Sony Ericsson then are the remaining players. Interestingly, you see that there's a lot of other mobile manufacturers out there as well, which together make up a fairly large market share as well. One of those, of course, that needs to be mentioned is Apple, who have recently launched their 3G iPhone on the 11th of July globally. It'll be interesting to see what sort of new smartphones are now going to come on the marketplace, given the exciting euphoria around iPhone and what it has to offer. So that just gives you a bit of an overview of, where things fit in and relative scales, and how fast things are moving. So earlier I talked about the technology. Now on slide 8, you'll get an overview of this evolution of technology. So we start off by noticing that some mobile technologies have a high degree of mobility, and some have a very low level of mobility. So the lowest level of mobility is, of course, fixed line networks, where you have a copper wire or fiber or something like that. At the lowest end of the spectrum is dial-up, and still in many markets, even in Australia, there's a large percentage of people still on dial-up broadband, which is quite surprising. But in many other markets around the world, that's a very low number. But most people in Australia today have some sort of DSL type technology for fixed broadband. So if we talk about broadband, we're really looking at more than 1 megabits per second down to your device. That's a fairly well accepted benchmark, if you like. Interestingly, the mobile technologies were always voice only, right? They started off with voice, and then they became data capable, and the data was in the form of SMS. And you could probably say that SMS isn't really data. It's only a few text characters, and you can't really do anything significant with it. But then that was improved with GPRS and Edge that came along. So you see that up the top. And some people call that 2.5G technologies. When 3G was first launched in October of 2002, it was launched in Japan and also in Germany roughly around the same time. NTT Docomo in Japan and Deutsche Telekom in Germany. That was probably the first time that we really saw decent throughputs on your mobile phone. You could get around 384 kilobits per second to your mobile phone, which is quite substantial. And at that time, that would have been considered, broadband, I suppose, right? Most people were probably on 256 and 512K DSL plans at that point in time. So for the first time, mobile technologies were starting to get close to speeds that were offered on fixed line telephony as well. So that's an interesting merge that we're starting to see happen. So how does our behavior change? Are you willing to give up your DSL broadband line for a mobile broadband line only? Now, there's some people that do that. And if you look at some of the plans that are out there in Australia today, if you take Vodafone, for example, you can buy a $39 a month plan and you get 5 gigabytes, which is quite substantial. Now, the data rate might be very low. Sometimes it might be very high. There's no guarantees. But you have the same issues on DSL as well, depending on how far you are from the exchange, the quality of the copper, what type of modem you're using. So what we're seeing is that mobile is getting close to DSL type technologies in terms of speeds. But one caveat here is that you can never ever be as good as fixed line telephony or fiber, for example. You have inherent problems with radio waves and radio propagation that will always limit the speeds that you'll get on mobile technologies. And you have the added benefit of mobility as well. So the fact that you're mobile means that you actually take some inefficiencies which reduce the throughput. So there are some wireless technologies then that are not mobile. So for example, Wi-Fi or wireless LAN like you see in your house today. So some of you might have a DSL router with a Wi-Fi connection to your laptop. That's called a nomadic mobility, meaning that you're in a very small geographic area and you're not moving very much, as opposed to fixed wireless access like WiMAX, for example, is being used quite a lot in fixed wireless applications. So what happens in that situation is you're seated in one place and you're connected to one base station and you generally don't move out of that environment. And because you're not moving, you're not having to worry about mobility issues, handovers, and those sorts of things. So the technology tends to be focused more on delivering higher speeds, but to a specific location. So there's a trade-off ultimately. But interestingly, 3G technology based on wideband CDMA, for example, has actually moved quite far. And the next evolution has been HSDPA, which is high-speed downlink packet access. It's a terrible acronym. For some reason, it actually grew out of the standardization. That's what they called it in standardizations, but now it's in everyone's product brochures. It's on marketing campaigns. It's a shame they didn't think of a much easier name than HSDPA, but somehow it managed to squeeze through. But more importantly, it started out as a 1.8 megabits per second downlink technology, and it went to 3.6, 7.2, and then 14.4. So those numbers are peak data rates, and those are data rates per cell. So that means if you and I all have a mobile phone with an XG card, for example, from Telstra, we're sharing that bandwidth. Okay, so that's something that needs to be understood. It's not a dedicated connection. Whereas the 384 kilobits that I talked about before was a dedicated connection to your phone. So if the network capacity in the cell could accommodate your 384 kilobit request, then you would get it. Generally speaking, that was unlikely because it's a very aggressive amount of power that's required from the base station. So most people were getting between 64 kilobits per second and 128 when 3G was first launched. And in more cases, it was actually 64. So 64 is very much like dial-up, isn't it? So I used to call 3G at that time. I mean, I was a big fan at the time. Obviously, I was involved in it. Mobile dial-up, that's effectively what it was. But as time has progressed, it's become significantly better. So if you try one of those, I don't know, how many of you have a mobile data card from 3 or Vodafone? Has any of you ever tried? So it's a PCMCA data card. You slot it into your laptop. If you go check out any of the operators today, you can see what their data plans are like, and they're quite good. But of course, it relies on the coverage that you have and wherever you live or wherever you're actually working. So you can get actually, I use the NextG example, which is a Telstra launch network. Are you familiar with the NextG network? Have you seen that? So NextG was launched in, I think it was October 06, something like that. It now theoretically has the capability to deliver 14.4 speeds to your laptop, but there's not many laptops that have that kind of capability. So most people can get in real life scenarios between 1 and 2, maybe 2.5 megabits per second to your laptop. So you run a speed test. It's quite interesting to watch. So I've talked about some of the technologies and the high level of the evolution. What's out in the Australian marketplace today. But if we go back to the industry perspective and look at who's really around today. So really, in essence, the telco industry is not just operators, because those are the people that you and I normally see. We're either on 3 or we're on Optus or Vodafone or Telstra, at least here in Australia. So to start off with, we have three main players. We have the infrastructure vendors. Now these are the guys who are actually developing the technology, such as Ericsson or Nokia Siemens or Alcatel-Lucent are the three big players. They're the ones who actually design, develop, produce, and sell the equipment to the telecom operators or the network operators. So those network operators are Vodafone, Optus, Telstra, and Hutch, for example. So they don't make their own equipment, they buy it from the infrastructure manufacturers. And they're called operators because they actually run the network. They operate the network. It sounds basic, but it's an important distinction to make. So what happens really is the network operator has a very close relationship with the infrastructure vendor. So in the case of Hutchison, for example, the infrastructure vendor is Ericsson, and Ericsson rolled and built out the 3G network throughout Australia, and Hutchison then started to operate the network. But then in time, Hutchison said, our core business is marketing. We want to focus on the consumer. We're not going to operate the network anymore. Ericsson, will you kindly take over this network and we'll pay you a fee every year to do this. So they transferred the whole operation and maintenance and support to Ericsson to do that kind of work. Another example is Nokia does the 3G network for Vodafone Australia and also Ericsson. So that's another example of a vendor, as we call it, infrastructure vendor and operator relationship. So what happens now? We've built the mobile network. We have someone operating it. Then what do? We need to have some services on top of it, right? We need to make some use out of the network. So the service providers are very important. So now in this situation, the operators traditionally have been the service providers. So you call up Optus and you say, I would like a mobile phone plan, thanks very much, and you're going to give me the service, and I'd like to have SMS with it as well. So in that case, the relationship that you had with the operator was also a service provider relationship. But now that we're moving into a data world, you don't have to get your data services from Optus anymore, right? You can get them from Google, it could be from Yahoo, it could be from Skype. It's a number of different players. So those are the service providers that, if you like, sit on top of the infrastructure. And those services then come to us from an end-to-end relationship. So what I mean is that you and I have a direct relationship typically with those end-to-end, with those service providers. So for example, you might be able to surf on your iPhone, YouTube, for example. So the relationship I have with YouTube is a one-to-one connection. It's just that I'm running over an Optus network, for example, or a Telstra network. So if you look at the scenario then of the traditional telecom world, which is what we had for a very long time, which is I call you and I pay then a fee to the service provider, which is the operator, for that service. So the telecom operator was the one getting all the revenue for all the work, so to speak. Now what happens potentially is that you can start paying Google or Yahoo or Video Easy or someone else for services that you get. So now what's happening is we're seeing a shift of revenue moving from the telecom operators to potentially these service providers. So that shift is starting to happen. It hasn't really happened in a big way yet. I mean, how many of you are actually buying content via your mobile phone? Let me give you an example. Maybe you are downloading songs via iTunes, for example. How many of you do that? Most of you are maybe peer-to-peer file sharing, I don't know, so maybe you're not paying for it. But some people are, there's a lot of usage in terms of iTunes as well. So what's happening there is that you're paying a monthly fee to your mobile operator who's getting a flat fee, and then you're downloading, volumes and volumes of data, and that revenue is then going off to someone else. So how do you think the telecom operator feels about this? Obviously, it's a somewhat threatening situation for their business model. So now what's happening is we're seeing a lot of pressure from operators to reduce cost and also to move into this new world where there's a whole bunch of content offerings that could attract a lot of revenue for that operator. The problem that everyone has today is, what is it that you and I are willing to pay for? No one really knows that. And also, how much are we willing to pay for it as well? Because if I told you you could get 12 pay TV channels on your, say, mobile phone, how much would you be willing to pay for it a month? Let's say it was 2 channels. If you're interested in sports and you were interested in European Premier League, as an example, how much would you pay for that one channel a month where you could get highlights? I don't know, pick a number. $3? Okay. And someone else might say, yeah, $3 is a pretty good number. And you'd be happy with something under $10 a month. Okay. And maybe some other channels, maybe movies or trailers or something like that. So if you take the number of subscribers that, say, for example, Vodafone have, which is roughly around 4 million subscribers, let's assume 10% of those are the ones who are only interested in watching TV on their phone, and then multiply that by $3 a month. That's how much revenue that the Vodafone is likely to get, right, from that service. So that's a compelling proposition. It becomes very interesting. But the problem is that Vodafone doesn't have rights to the European Premier League. That's held by pay TV, which is Foxtel. So if Vodafone went to the European Premier League, for example, and said, look, I wanted to now license mobile TV on my phone, how do I go about doing it? They're going to have to pay a huge amount of money for that service. So for example, Three, I think, if you're not aware, they have an agreement with the Australian Cricket Board, and you're able to watch cricket on Three mobile phones now. So Three has said to themselves, okay, look, we want to become a media telco player. Infrastructure is important. Without infrastructure, I can't compete. Otherwise, I have to then borrow the service of someone else, like Telstra. Telstra will then obviously charge a huge amount of money to Three for a service because they built the infrastructure, right? So you've got this issue of having to build your own network. And these networks cost, for example, Three publicly stated in the beginning that they were going to spend around $3-4 billion on their 3G network, which is a huge amount of money. And if you're only getting $50 a month from a subscriber and you have 1.5 million subscribers, you can think about how long it takes to actually make profit on a deal like that. So it becomes very important where this revenue is coming from. And keep in mind that you and I are still sending SMSs and we're still making voice calls, so that revenue is still there. But there's a new pot of gold sitting somewhere that no one really knows much about. How big is it and what does it look like? So it's interesting to be aware of that and see where things go. And then the last piece of the puzzle in terms of the industries is we talked about the infrastructure vendors, we talked about the telecom operators, the service providers, and the investors as well. Who are the people or the organizations that are funding or owning part of these telecom operators? And these are, of course, the financial community. So the investment banks and the fund managers and those sorts of people. So you may have seen some of these names before. This is just a slide here to remind you to look at the financial community as well, because they also play a very important part. Mostly in terms of the valuations of the telecom companies. So they're always generally saying that you should buy or sell a stock based on how well the company is performing. So for example, if Telstra wants to build a brand new mobile network like it did with NextG, and it's going to cost $1.2 billion, of course the shareholders are going to want to say something about that. And the shareholders aren't necessarily you and I, they're very large financial institutions that own them. So they have a very big say in where things go. So if we switch now to Australia and look at some historical data around mobile subscriber growth. Australia is roughly 21 million people. I mentioned the penetration is around 105%. So you can see here how the growth has been. So from 2002, we had roughly 65% penetration, and that's grown quite substantially. And you can see the dark blue line with the bar, which is GSM. It was growing quite fast until 2005, and then it started to decrease due to significant take-up of 3G technology in Australia, which has been quite interesting to watch. So when did that all start? So if we look at 2003, we can see the first 3G network was launched by Hutch in April, as I mentioned. So they were essentially the pioneers in Australia. At that point in time, Telstra and Optus were pretty lazy when it came around to 3G, and Vodafone wasn't all that interested in it either, although it was starting to look for vendors to roll out a network. Keep in mind, we have two very interesting players in the Australian marketplace, which are Hutch. They're a global player. You know, they're in, what is it? I don't know. I think it's 8 or 9, 10 countries, based out of Hong Kong. And Vodafone, of course, is a Vodafone company from the UK, so it's a global organization. Last count, I think they must have somewhere around 120 to 40 odd million subscribers globally when you add up all of their interests. Telstra is local, and Optus is also, of course, how could I forget, is owned by Singtel, Singapore Telecom. So we have three global players that have presence here, essentially, plus a very large player in the form of Telstra. So Hutch really made a big move by launching, and that made the others wake up. And soon followed a couple of years later with the launch from Vodafone, Optus, and Telstra as well. And then more interestingly, Telstra made a very interesting announcement that at that time, in around 2005, Telstra had three networks. They had a GSM network, a CDMA network, based CDMA 2000 network, and a 3G network based on wideband CDMA. So they said to themselves, well, hang on, maybe I should sort of rationalize and consolidate my networks to save cost. And so they decided to shut down their CDMA network and then build out a wideband CDMA network instead. So they didn't really build it up from scratch. What they did was they went to the same sites and swapped out the base stations and made lots of changes to that site to make it work, and built an entirely new, or expanded their core network to make that happen. So that was a pretty big undertaking, and I have a couple of slides on that later on to give you a bit of an idea on that. So the interesting thing about the Telstra network was they promised to cover 98% of the population with 3G already from day one, which is a pretty phenomenal number when you look at Australia's diverse geography and sparse population then in that case. So that meant a huge number of base stations that needed to be deployed around the country in order to make that happen. At that time, the coverage from most of the operators was around 50 to 60% of the population, so quite low. So Telstra really leapfrogged the competition in that case. So when that announcement was made, and the vendor at that time, the vendor that helped them roll that out was Ericsson, they rolled out 6,000 base stations in a 10-month period, which is a phenomenal rate of rollout. I think the number was around 28. Every 28 minutes they were turning on a base station over that time, some number like that. So what we've seen now is that Vodafone and Optus have responded, and they're going to roll out rural coverage to 3G to about 96-98% as well, because they just have to keep up. So we're seeing about 32% of Australian subscribers are now on 3G networks, which is of the highest globally. So this chart here shows you, it overlays the penetration figure, which is the line chart, and the number of subscribers there. And then if you want to look at the market share, so who's the big game in town? And right now it's Telstra with 43% of the market share for mobile subscribers. Second with Optus at 32%, so they're quite close to each other. And a distant third with Vodafone, and then Hutchison is only about 7%. But keep in mind, Hutchison came from nothing. So they started with an Orange network in Australia, which was a CDMA-based network. And then they launched 3G in 2003. But to gain 7% market share from where they were in the beginning was quite a substantial achievement on their part, I would say. So they've really made a big change in the Australian marketplace. Optus has been dawdling around that market share for quite some time, and Vodafone has always struggled and stayed number 3 for a very long time. So what does that look like in raw numbers, just to put a feel to it? Telstra has around 9 million subscribers, Optus 7, Vodafone 4, as I mentioned, and Hutch 1.5 million, just to give you a bit of an idea. And as I said, 3G makes up almost 1/3 of the subscriber base, which is quite significant. So earlier I talked about in slide number 8 about fixed broadband, if you like, fixed wireless and mobile wireless. So just to clarify, mobile and wireless are two different things, although we use them interchangeably. So when we talk about wireless, it means that it's effectively a connection without wires. That sounds a bit stupid, but mobile means that we're actually fully mobile, meaning that we can go anywhere, anytime, essentially. So wireless is effectively, we can sit down, we have a wireless connection, but when we move, we don't necessarily have mobility, okay? So if we're seeing that mobile technologies is now starting to get very interesting in terms of downlink data rates, getting closer to fixed line telephony, then it's kind of interesting to look at the entire broadband market for Australia, combining fixed and wireless. So if we look at the wireless percentage of broadband within Australia, it's around 11%. Other technologies are like cable, so Optus cable and Telstra cable, which is based on a hybrid fiber coax connection, or HFC network as they call it. There's very little fiber in the marketplace today, but most people are on DSL technologies, which is on copper. So if we look at the wireless subscribers then in that case, looking at both mobile and fixed wireless, we can see unwired come up as well, which have about 14% share, and there's a bunch of little players as well, which make up an interesting slice of this as well. So when we talk about wireless broadband now, it's services of theoretically more than 1 megabit per second. So you can see that Telstra captures the large piece of that now with 66%. Now that was if you look back about 2 or 3 years ago, that would be a very, very different picture, because when Telstra shut down its CDMA network, which had around 1.5 million subscribers, almost all of them moved on to the 3G network for NextG. So they effectively became wireless broadband overnight. So that number has allowed Telstra to dominate, if you like, in the wireless broadband arena. But prior to that, Hutchison was actually having a very significant piece of the pie at that time.
Was there a policy of Telstra to get the broadband?
Say again, sorry?
Was there a policy of Telstra to shut down the CDMA?
Yeah. So why was the policy, or?
Was that policy?
Yeah. Well, it was a strategy, I would say. So the strategy was. So the question was it a strategy of Telstra's to shut down the CDMA network? And it was for 2 reasons. First was to reduce cost from having 3 networks and make them 2. And secondly, they realized that if they built out a very powerful network with great coverage and good downlink data speeds, that they would be ahead of the game. So, and they were, and it was a very good strategy that paid off. So now what's happened is 2 years later, Vodafone and Optus still aren't really able to challenge the NextG network in terms of coverage. By the end of this year, both operators believe they will have roughly the same coverage as Telstra. That's true to a point. But in terms of capacity and downlink speeds, Telstra still is ahead of the other players. So they've been able to capture a lot of the broadband business. Now, if you think of mobile broadband, it's more useful at the moment for business consumers. Those are the ones that have taken up the mobile broadband offering from Telstra. So which are the laptop users? They stick a card in and off they go. They're checking their email. It's as if they're in the office. Nothing is different. You and I are now starting as consumers to pick up on that as well. But because they've got a head start, as you can see here with a 66% market share, they're making quite significant margins on that as well. So now I'd like to take you back just quickly into history a little. The chart's a little bit messy here, slide 15, but if you look at the line chart, it's showing what's called CapEx, which is capital expenditure. This is what each year a telecom operator will spend on its infrastructure. Okay, and if you divide that by sales, which is the revenue that the mobile operator is getting at the time, you get a bit of an idea of how aggressive their infrastructure spending is for that year. So if you look at the late 90s, you can see that a CapEx of around 20 to 40% was quite typical, which is huge. We don't see those sorts of numbers anymore in the industry today. It's very, very rare. So at that time, everyone was building out GSM networks in the late 90s, and that sort of fits in with our understanding of how things have worked. But those were pretty much Western European countries and a little bit of North America. Not much was happening in Asia at that time. And then you can see the chart, which is really interesting. It peaked up at around 2001, which, if you do recall, was around the IT boom. Everyone was talking about this IT bubble. And then soon after the IT bubble in 01, 02, you can see a massive collapse. And the reason for that is that operators couldn't really afford to spend money on infrastructure anymore. So they stopped spending money on that. And so the CapEx went down. And so the ratio dropped significantly. So it's an indicator of that. And at that point in time, what it meant was, who do you think was affected when the CapEx was basically shut down by many of the operators? So it was the infrastructure vendors. So the manufacturers, the Ericssons, the Nokia, the Lucent, and Alcatel, the operators weren't spending money on them anymore. So what we saw is that the 6 big players all started to face some pretty serious financial trouble because the market suddenly collapsed. So as a rough example, around 2001, Alcatel's popular number of employees went from 135,000 to about 35,000 employees in 2 years. Nortel's was roughly the same. Ericsson went from 100,000 to 60,000. So we're looking at over a 2 to 2.5 year period, most of the telecom manufacturers lost 40 to 50 to 60% of their employees because they made them all redundant and they had to shrink. So it was a very tight time in the industry. So cost became a very important issue. Now keep in mind that 3G had just been standardized and released in 99, and the networks were starting to be rolled out in 01 and 02. So 3G was meant to be this big burst that was going to happen and, you know, really take the market forward. So that ended up becoming delayed, and we saw that things started to warm up in around 2003, 2004, and as you can see, that corresponds nicely with the capex to sales curve that you can see here. So operators started to fix up their financial situation, they started to see revenue growth, they started to spend more money, they started to build more networks. And then you can see why companies like Optus and Vodafone held back during that period, because it was uncertain what 3G could deliver, and also a lot of these companies were financially constrained, and so was Telstra. The anomaly here was Hutchison, of course, which had a huge amount of money at that time and was able to invest globally and start building out 3G networks. So the parent company, Hutchison Whampoa, had a telecom operation, which is essentially the Orange network, which they sold for about $20 billion just prior to the IT crash. So they were cashed up and ready to go. So it was extremely smart investing on their part. But that helped really, in effect, I would easily say, trigger the 3G development globally. So they played a very important role in the telecom industry. So if we look at, for some reason, hang on, where are we? If we go to the next slide, slide 16. For some reason here we go, the numbers have popped up. So EBITDA is essentially profit, or profit margin, earnings before income, taxation, depreciation, amortization. Don't worry about that. Essentially, it's an indication of profit. So Telstra's profit margin, if you like, is around 43%, which is quite high. And Telstra is what we call a telecom incumbent, which is the original telecom provider for that country. And in most markets around the world, the telecom incumbent was privatized or sold or became public and then ended up on a stock exchange. So telecom incumbents' profit margins typically rank around 40 to 45%, which is quite high. Some markets in Asia, it's even higher. Like if you take Telecom Indonesia, for example, their margins around 60%, which is extremely high. So if you look at the other players, for example, you see Optus Vodafone in Australia are around the 20 to 25% profit margin, which is significantly lower and more typical. But the interesting point is when you add up all the profit dollars from all of the companies around in Australia in the telco market, and then you look at Telstra's share of the total profit, they make up 77%, which is significant. So with only 45% market share, they're able to capture roughly 80% of the market profit, which is huge. I mean, that really indicates that there's a significant amount of dominance that Telstra plays in the marketplace in Australia. They really are quite large, and it's very difficult then for the other players to compete. So there's always issues around monopoly concerns. Is Telstra too strong? Should we break it up? Should we split wireless and mobile, fixed and mobile together, or wholesale and retail? And those sorts of discussions are always happening, but of course very difficult to invoke. And usually what will happen is a regulator in the country will then make a decision on whether that should happen or not. So if we move on to the next slide, as I mentioned, the Telstra example is quite well known globally for being a very fast rollout of around 6,000 base stations, compared to Telstra's 3,000 for its CDMA network, which they replaced. So in order to cover 98% of the population, they had a significant rollout. And then more importantly, Telstra, I would say, for many years was a sleeping giant, and they were quite happy with their monopoly business, and they weren't really investing in technology probably in the mid-2000s. And in the last couple of years, they've decided that technology is decided that technology is a very important advantage for them, and they've decided to invest heavily. Hence the next year rollout, and they've got a very aggressive rollout plan as well. So if you look at the 3GSM line on the very top there, you can see that pretty much, they've rolled out the network to 14.4 megabits, and they're now looking in 2008 to have trials of around 21 megabits per second to your mobile phone, which is pretty huge. It's a shared connection, of course, but that's a significant peak. Even if you were to get 1/10 of that speed, which is 2 megabits, that would be a pretty good service compared to your fixed broadband, wouldn't it? So it's becoming quite comparable. So those speeds will probably be offered only in metro areas, I would imagine, not everywhere. But in time, I think it would start to move out. And also what's very important is the continued evolution of the mobile technology as well. And that's moving to something called LTE, or long-term evolution. So long-term evolution is being standardized at the moment, and speeds of around 100 megabits per second to the phone are being looked at, which is quite significant, shared again. And in 2013 onwards, we're looking at 4G technology starting to come into the marketplace. So these speeds that I'm talking about are between the mobile phone and the base station. Is that clear? So we're talking about radio link speeds, so the first hop from the phone. So what's very important then is if these data rates are starting to move up very, very fast, going from 14 megabits to 100 megabits per second, that's between us and the mobile base station. It presents a very big problem then for something we call backhaul, or mobile backhaul. So how do we transport all that large volume of information from the mobile base station back to the back end of the network? So before it was just voice calls, and a voice call would normally, on a mobile air interface, would take up around 8 kilobits per second. So on your GSM phone, that's the only data rate that we're using. And SMS is a few text characters, and that was it. So early mobile networks were built on very, very small backhaul links, either microwave or E1 links. And those E1 links were typically in 2 megabit per second chunks. So you'd have a mobile phone, we would talk to a base station. The base station would have a 2 megabit link to the core network, essentially. And that would be all that would happen. So if we have a mobile base station now that has a speed of 14.4 megabits per second, that 2 megabit pipe is not enough now, right? You need 7 of those to actually make that connection work. So we have two pieces of the puzzle now. We have the air interface speed, which is what everyone talks about in the press, and it's a peak speed. And then we have the backhaul connection as well, which is extremely important. So what backhaul technologies are there that could support 50, 100 megabits per second that you know of today that makes sense? Something that we use here quite commonly. Begins with E. Ethernet, yeah. So Ethernet technologies are now becoming more and more interesting in the mobile radio access network. So before we had TDM connections on 2 megabits with E1 links, very old archaic systems. Now we're having to boost up those data rates, and now Ethernet is cheap, it's fast. So why don't we convert the whole radio access network into an IP network, just like our campus network that we have today? Why can't we have a mobile base station connected to a LAN, effectively? And that's what's starting to happen. So you can see a shift in the industry as speeds start to go higher and higher. It presents more and more problems for the infrastructure. So the infrastructure has to develop and evolve as well in order to accommodate that. So on this slide here, you see Ethernet backhaul as being an important piece of the puzzle. Now, interestingly, because Telstra has a lot of fiber connectivity around Australia, most of its base stations are actually connected to some fiber network already, which is a significant advantage. So not only do they have a strong offering on the air interface, they also have very good backhaul networks, which can deliver the data rates quite cheaply to the rest of the network. So that's a very important piece of the radio access network that we'll talk a bit more about as time comes. So if we look at, this is an interesting picture I picked up from Ericsson actually. This is the original phone in 1878. It's interesting to see what it looked like, and now what do we have? It only stops at 2004. Of course, it's a bit old, but now we've got full multimedia, voice, video conferencing, all sorts of really interesting stuff on it. So, that's a very important piece to look at as well. So the networks are evolving, they're getting faster and faster, but at the same time, our mobile phones need to make use of these networks. Otherwise, there's not much point in doing or in having this great evolutionary piece, if you like. But the point at the end of the day is it's got to be useful for you and I. You know, these phones might be great, but if we're not using it, it's got to be compelling. It has to be interesting. So what we're looking at going forward then is, as I mentioned before, the content. How will the content look? So that might be a good point to have a short break for about 5 minutes. Maybe we could get back at about 8 o'clock, I think, if that works out okay. Should I stop that?
You can pause it.
Ooh.
Yeah, stop.